this lesson, we're going to talk about slope, or rate of change. There are 4 different slopes: positive slope, negative slope, zero slope, and undefined. You can see them here in these 4 pictures. Let's talk about the first one. Anytime you're looking at the slope of a line, you're going to read it from left to right, just like you're reading a book. So you can see that this line is going upwards from left to right. This will represent a line that has a positive slope. The next one is a negative slope. Same rules apply. Reading left to right, you can see that the line is going downward. That means that it is a negative slope. The next 2 are a little bit different. Zero slope. Zero slope means that the line is going to be a horizontal line. I like to think of a treadmill where before pressing the incline button to make the slope rise or fall, it begins at 0. And the last one, an undefined slope. I like to think at this little biker here, it's undefined what's going to happen to him if he rides along this vertical undefined slope. The variable that we use for slope is m. Sometimes we hear these little terms. One is rise over run. I'll show you how to use rise over run on the next slide. We also can say that slope is the change in the y over the change in the x. This little triangle here means change. So let's go ahead and talk about how to use this idea of rise over run and change of y over change of x. Let's take a look at some positive slopes. Here is a line, and we can see, but just by looking at it, that the answer is going to be a positive number because the line is positive going from left to right. Let's go ahead and look at the points. I want to get from one point to the other by rising and running. So I'm going to go ahead and put little lines in here and to show you that it's rise over run. So I'm going to rise 1, and I'm going to run 1, 2, 3, 4, 5, 6. So my rise was 1, and my run was 6. So the slope of this line is 1/6. Looking at the next one, you can also see just by looking at the picture of the graph that it's a positive slope. So let's go ahead and pick the point, and I'm going to rise, and I'm going to run to the other point. My rise here was 2, and my run was 1, simplifying this to 2. You always have to simplify your fractions. So in our case here, our slope was 2. Now, let's say that we chose another point. Let's say that we chose this point on the line and this point on the line. I'm going to rise 1, 2, 3, 4, and I'm going to run 2. So my rise was 4 and my run was 2. And again, if I simplify these fractions, it gives me a slope of 2. Just for one more example, let's go ahead and use this point down here and this point way up here. I'm going to rise 1, 2, 3, 4, 5, 6, and I'm going to run 1, 2, 3. That gives me 6 over 3, which simplifies to 2. So no matter what 2 points that I use on the line, it'll always simplify down to the same slope. And in our case, the slope is 2. I do want to make one more comment about the slope. Now, for all of these examples, I have gone from the lower point to the upper point. I'm going to go ahead and go the other way. So I'm going to start at this point here that I'm highlighting, and I'm going to rise to get to the other point. So if I rise, you can see that I'm going down 2. So in this case, my rise is -2, and my run going to the left is -1, giving me a slope of -2 over -1, which you can see that it simplifies down to 2, just like the others. So it doesn't matter which point you start with, as long as you're accounting for the positive and negative movements. Well, now let's look at 2 negative slopes. You can see by the picture that both of these are negative. Let's go ahead and calculate. I'm going to start at this point here, and I'm going to move to the other point. So I'm going to rise -3. Be very careful to represent your negative. And I'm going to run +4. -3/4 does not simplify, and therefore my slope is -3/4. And the last one, I'm going to go ahead and I'm going to start at this one. I usually like to start with the one on the left and move to the right personally. So I'm going to rise -3, and I'm going to run 3. So rise -3 and run 3. That's going to simplify down to -1. So my slope in this case is going to be -1. All right, let's look at these two graphs of one with 0 slope and one with an undefined slope. I'll show you how this works. So let's look at the first, a 0 slope. Any horizontal line will always be a slope of 0. Here's why. I'm going to go ahead and I'm going to start with this point here that I'm highlighting. And if I say how many do I rise to get to the other point, well, we're not going to rise anything, so I'm going to place a 0 there. And then if I run, in this case, I'm going to run 4 spaces. So my run is 4. We know that 0 divided by any number is always going to be 0. Therefore, making the slope of this line 0. In this example, this is an undefined slope. Also, it's just a vertical line. So let's go ahead and do that rise over run thing. I'm going to go ahead and I'm going to start with this point. I'm going to rise 2 units. And you can see that once I get there, I'm not going to run to the left or right at all. Therefore, my run is 0. Anytime you try to divide by 0, the calculator will most likely say error. You can't do it. You can't divide something into 0 groups. And therefore, this is an undefined slope, which will be represented by U and D. Okay, now we're going to determine the slope from a table of values. We've been doing a little bit of talking about tables of values, so now we're going to be able to determine what's the slope of the line given a table. So let's take a look at this first table here. What I want to do is I want to figure out what my change in my y over my change in my x's are. This is rise over run. So let's go ahead and figure out the changes in the y's. If I go from 5 to 7, that's 2 units. If I go from 7 over 9, that's also going to be 2 units. And 9 to 11, the change is also 2 units. When I talk about the changes in the x's, this one is just going to increase by 1, another time by 1, and another time by 1. What I want to do is I want to take that change in y and divide it by the change in the x. So in our case, 2 divided by 1 simplifies down to 2. Therefore, the slope of this first one is going to be 2. Let's look at the second example because it's a little bit different. Let's look at the changes in my y's. In this case, it's going to be 1, 1, and 2. For my changes in my x's, it's going to be 2, 2, and 4. Now you can see that the numbers are a little bit different, unlike the first one, but let's go ahead and look at it. My change in my y divided by my change in my x will give me 1 over 2, which is simplified. Now let's look at the one down at the bottom. The change was 2, and the change here was 4. So if I take 2 and divide it by 4, that is going to simplify down into 1/2. So even though those numbers were different, your slope is still going to be the same. So m is going to be 1/2. Okay, now let's go ahead and take a look at the formula for slope. This is a formula that you will need to commit to your memory. The formula is m equals y2 minus y1 over x2 minus x1. The y2, y1, x2, x1 are represented by coordinate. So these coordinate points, it says here, determine the slope of the line between 2 points using the slope formula. Where I get this whole x1, y2 is right here. Let's go ahead and label them. x1 and y1, x2 and y2. Now, you didn't need to name the first point, x1 and y1. You could have named the second point, x1 and y1, as long as the 1s and the 2s stay together at the same coordinate. Now, let's go ahead and let's fit this into the formula. M, which is our slope, is equal to y2, which is -6, minus y1, which is -8. Notice how I'm using parentheses. x2 minus x1 is my denominator. All right, now what I want to do is I want to go ahead and just look at it. A plus and a plus, I'm sorry, a minus and a minus, this is actually going to create a plus here. giving the numerator as 2. The bottom, a negative and a negative next to each other being multiplied, is also going to make a plus, giving us 18. 2/18 is unsimplified, so we have to take it down, and we have to simplify it to 1/9. The slope of this line is 1/9. Now, what does that mean? These 2 points are 2 points that lie on a line. I'm just going to draw just kind of a random line. These are 2 points that are on that line, and we just found the slope of the line given those 2 points. Okay, let's look at this next example. This is kind of a unique example here. Let's go ahead and label our x1, y1, and x2, y2. All right, let's plug it into the formula. M equals -14 minus 0 and 3 minus 10. I'm going to go ahead and simplify it this time. Notice that there aren't any negative negatives. There's just a minus sign, which is fine. So my numerator is -14 divided by -7. I'm going to simplify that down to +2. So the slope of this line that contains these 2 points is 2. Now let's think about these 2 at the bottom here. Think about what happens when your x values are the same. Well, if we have the changes in the y's over the changes in the x's, you have to think about what's going to actually happen here. If your x values are the same, that means they're going to cancel each other out, and you're going to be left with 0 in the denominator, with something else up top. If you have a situation like this, you know that your slope is going to be undefined. Similarly, in these 2, you can notice that your y's are the same. So when we look at that change in y over change in x, my y's will end up canceling out and giving me 0 over a number. In that case, your slope will be 0. Those are 2 really good things to just kind of keep an eye out for. Okay, the last thing I want to go over today is an application of slope. Let's determine the value of y so the line that passes through the point -2y and 6, 7 has a slope of 1/2. So basically, I'm just going to kind of draw a little picture here to show you what's happening. I have 2 points. I know that one of them is 6, 7, and he's about right there. And I have another one that, let's just say he's right here. I don't know where he is, but let's just say this is -2y. And I know that the slope that's of this line that's going through these 2 points is going to be 1/2. I want to figure out what is that y coordinate of that first point. So here's how we're going to do this. I'm going to set up my slope formula. M equals, and I'm going to take my coordinates, and just like before, I'm going to label them x1, y1, x2, y2. Now, what's different in this problem is that I know the slope. So I can set it up as my slope of 1/2 is equal to my y2 minus y1 over x2 minus x1. I'm going to take it one step further and just simplify whatever that I can here. My numerator is already simplified, and my denominator here, 6 minus -2, turns into a plus, giving me 8. This probably looks familiar to you from the equations unit. This is a proportion. I'm going to use my knowledge of proportions to finish solving this problem. So here we go. I have 1 times 8 is equal to 2 times 7 minus y. I'm going to go ahead and solve this problem. I'm going to go ahead and distribute. And then I'm going to go ahead and I'm going to subtract 14 from both sides. -6 equals -2y. And I'm going to divide both sides by -2. Y is equal to 3. What that means is the y coordinate in this point is 3. So we can replace this one with a 3. What we did there is we solved for an unknown variable given information that we needed to solve the problem. All right, that brings us to the end of our lesson on slope and rate of change.